Today we will be talking about the first derivative test. We always solve derivative by using the power rule, product rule, quotient rule, and chain rule. But what do we use them for? The first derivative test helps us to graph an equation, and it specifically helps us to find when is the function increasing or decreasing, and to find its maximum and minimum values. This is the most important thing that the first derivative test helps us with. Let's go straight to an example. We'll have f of x is x squared plus 2x minus 3. Now, to solve the first derivative test, of course, we'll first do f prime of x. And we'll find f prime of x by doing the derivative of f of x. Derivative of x squared is 2x, and the derivative of positive 2x is 2, and the derivative of negative 3 is 0. Now for the first derivative test, we always equate the derivative to 0, and we solve for x. To solve for x, we take the 2 to the opposite side, where it becomes a negative 2. And now we'll have 2x equal to negative 2, and to find x by itself, we divide the function by 2. 2 over 2 is 1x, and negative 2 over 2 is negative 1. Now, since we have x equal to negative 1, we need to do a table where we have x, f prime, and f. This table helps us know where is the function increasing and decreasing. And of course, our domain here is from negative infinity to infinity, since we don't have any restrictions or conditions. So we'll have negative infinity to infinity, and we have our special value, which is negative 1. And put a 0 here. Why did we put a 0 here? This 0 means f prime at negative 1 is 0. Now, we take something called test values. Test values means we take a value between negative infinity and negative 1, and the value between negative 1 and infinity. Let's take negative 3, for example, here, and let's take 0 here. These two values, we replace them in f prime of x, so that we can find if the function is increasing or decreasing. If the value that we get is a negative number, the function is decreasing. If we get the number to be a positive value, then the function is increasing. So first we replace negative 3 into the f prime. We'll have 2 into negative 3 plus 2, which means negative 6 plus 2, which is negative 4. As you can see here, our value is negative. So it's negative here, and our function is decreasing. Now, if we replace 0, we'll have f prime of 0 is 2 into 0 plus 2. 2 times 0 is 0, and we'll have 2. 2 is a positive number, then from negative 1 to infinity it's positive, then the function is increasing. And here we can write our function f is increasing from, as you can see, it is increasing from negative 1 all the way to infinity, since it is a positive here. And function f is decreasing from negative infinity to negative 1. Now, the first derivative test helped us see when is the function increasing or decreasing. We need to find now if we have a maximum or minimum. As we can see, our function decreased first and then increased, which leaves us with a minimum. Whenever our function decreases and then increases, we'll be left with a minimum. But whenever our function increases and then decreases, for example like that, we'll be left with a maximum. In that case, we were left with a minimum. So we have a minimum at x equal to -1. Now we need to find the y value for our minimum. So we'll find f at -1, which means we replace -1 into our x squared plus 2x minus 3. So we'll have -1 squared plus 2 into -1 minus 3, which means we'll have -1 squared is 1, positive 2 times -1 is -2, minus 3, which will be left with -4. So our minimum is at, of course we usually write them as x and y. Our minimum is at -1, -4. Let's do another example. Now, as we said, we need to find when is the function increasing or decreasing and whether we have any maximum or minimum. And the first derivative test helps us do that. To find that, first we'll need to derive. So we'll find f prime of x. F prime of x is 2 times 3, which is 6, x squared, minus 6, plus 2 will become 0 since it is a constant. And we equate it now equal to 0. Now we solve for x. We take the -6 to that side. So we'll be left with 6x squared equal to 6. And now we divide by 6. We'll have x squared is 1. X squared is 1 means we have two solutions. X is -1 and x is +1. Before, in the table, we had only one solution here. But now we'll be having two solutions. And of course, our domain is from -infinity to infinity because we don't have any conditions. We'll be doing our table. We have x, f prime, and f. And now we have two values here, -1 and 1, and from -infinity to infinity. Of course, we move in an increasing order. That's why we put -1 before. Now, as we said, we put zeros here because f prime at -1 is 0 and f prime at 1 is 0. And we take now test values. We take a test value between -infinity and -1, a value between -1 and 1, and a value from 1 to infinity. Let's say we take -2, 0, and 2. And now we replace. F prime at -2 is 6 into -2 squared minus 6, which means 6 times -2 squared, which means 4, minus 6, which is 24, minus 6, which is 18. Our number here is positive, which means our function will be increasing. Now, we find f prime at 0. So 6 into 0 squared minus 6, which means 6 times 0 squared is 0, minus 6, so our answer will be -6. -6, we care about the value, the sign. The sign here is negative, so our function is decreasing. We now replace also at 2. F prime at 2 will be 6 into 2 squared minus 6. 2 squared is 4, so we'll have 6 multiplied by 4 minus 6, which is 24 minus 6, which is equal to 18. 18 is a positive value, then our function is positive here, and it is going up. Now, as we found here, our function f is increasing on two intervals. The interval here from -infinity to -1 and the interval from 1 to infinity. So we write increasing from -infinity to -1 union 1 to infinity. And it is decreasing on one interval, which is from -1 to 1. So we write f is decreasing from -1 to 1. Now we'll need to find whether we have maximum or minimum or both. As we can see from the arrows, we say that our function increased and then decreased and then increased, which left us here with a maximum and left us here with a minimum. It means our maximum will be at -1 and our minimum will be at 1. So we write max at x equal to -1 and minimum at x equal to 1. And of course, to find the y value, we need to replace in f of x, where we have f of x is 2x cubed minus 6x plus 2. And now we just replace into f of x. So f at -1 is 2 into -1 cubed minus 6 into -1 plus 2, which means -1 cubed is -2, -6 times -1 is +6, and plus 2, our final answer will be 6. We do the same now to find the minimum. Minimum, we replace f at 1, which leaves us this 2, 1 cubed minus 6 into 1 plus 2. 1 cubed is 1, 1 times 2 is 2, so 2 minus 6 plus 2 will be left with -2. So our minimum is at 1, -2, and our maximum is at -1, 6. And of course, the y value of the maximum should be greater than the y value at the minimum. Let's do one more example. As we said, to find when is the function increasing or decreasing and to find the maximum and minimums, we'll need to do f prime of x. So the derivative of it will be -3x squared plus 9 equal to 0. And we equate it equal to 0 to be able to solve for the x values. Now to find the x, we'll take the 9 to the other side, which will leave us with -3x squared equal to -9. And now we divide by -3, which keeps us with x squared equal to 3. Now, since we have x squared equal to 3, we need to perform a radical on both sides. So we'll be left with x is positive or negative radical 3. We do the table. X, f prime, f, and our domain here is from -infinity to infinity, since we don't have any conditions. Of course, we'll do some problems with conditions later on in another video. So from -infinity to infinity, and as we said, we go in an increasing order, and negative radical 3 is smaller than positive radical 3. We have negative radical 3 here and positive radical 3 here, and we put zeros on them. And now we take test values between -infinity and negative radical 3. Let's take -3. Between negative radical 3 and radical 3, we'll take 0, and here we'll take a 3. And we replace them in f prime. So f prime of -3 is -3 into -3 squared plus 9. -3 squared is 9, -3 times 9 is -27, plus 9, which gives us a -18. Our value is negative, which means our function is decreasing. Do the same for 0. -3 into 0 squared plus 9, where we'll have 9. 9 is a positive number, so then our function is increasing here. And f prime at 3, -3 into 3 squared plus 9, which is -27, plus 9, which is -18, negative decreasing. So now we write function f is decreasing on two intervals here. We have it decreasing from -infinity to negative radical 3 and from radical 3 to infinity. So function f is decreasing from -infinity to negative radical 3 and radical 3 to infinity. And function f is increasing on one interval, which is from negative radical 3 to radical 3. Now let's see where is our maximum and where is our minimum. As we said, our function decreases and then increases and then decreases. So we have here a minimum at x equal to negative radical 3, and we here have a maximum at x equal to radical 3.